I'm like, I needed to be outside for a few minutes. So, and then Wien's law is about wavelength emission. So the maximum wavelength that some body is going to emit is directly related to its temperature. So like that's why infrared works on us when we're using the night vision goggles.
Right.
It emits a specific thing that we can't see with our eyes because our eyes do visible light, but with an infrared goggle we can see the heat signatures, so that's the level. It's a much slower, lower level of, or longer wavelength. Okay, so you're basically taking the constant 2898 micrometers or micrometers divided by Kelvin temperature. So you have to make sure you convert all your temperatures to Kelvin, whatever they give you, before you use this formula. Okay.
Okay.
And in the beginning, I talk about the temperature of the surface of the sun. I give you that temperature in Fahrenheit, so you have to convert it to Kelvin, and then do the two different calculations using the formulas. Okay. And once you have those formulas, then you can use whatever peak wavelength you get. You can look on here. There's better versions of this online.
Okay. I've seen
but
two of them already, just by looking at Wien's law and Boltzmann's law when we did chapter questions, I believe it was.
Yeah. And that's why I wanted to, I try to use the chapter questions to relate the chapters and the labs and get you thinking about stuff that I'm also going to quiz you on as well. So,
okay.
But this electromagnetic spectrum, there are better versions that give you micrometers instead of nanometers or whatever. So you can do more direct conversions, but because this lab is an OER lab, this had to be an image that was allowed to be used without copyright.
Okay.
So you can look up a better version that you could use, and it doesn't really matter. Okay.
Well, I want to find more micrometers. Is what you're saying?
Yeah, because that's what you're gonna calculate it in.
Okay.
Yeah, the Wien's law is in micrometers.
Yeah.
So it's hard to.
Oh, this is in nanometers. Okay. Yep.
Yeah.
Okay, I understand.
Okay.
So then that's going to tell us what our peak wavelength is. Here's wavelength falls in what portion? Okay.
And then let's see. So then the next part is about sun angles. And the key for sun angles is to think about, think about where you are on the Earth versus where the rays of the sun are perpendicular. So if I am located, if this is the equator, okay, and I'm at 20 degrees south, okay, but it is June. On June 21st, the rays are perpendicular at 23.5, which is the Tropic of Capricorn.
Right.
Sorry, Tropic of Cancer. I apologize.
Yeah.
Cancer is north, my brain, Okay, so I'm at 23. The sun's rays are at 23.5. So basically, I do 90 minus the location or latitude that I'm at, plus or minus where the rays are perpendicular, or the solar declination. Okay. And I'm going to give you specific dates. Those 4 specific dates you need to memorize. And then there's other times where we can actually do the calculation to find out where the rays are perpendicular, because they're going to move, just like you see our days are shortening right now.
Right.
Because where the sun's rays are hitting perpendicularly and its track across the sky, we're going to have the sun's rays at a different location. Actually, it's coming up to the equinox on the 21st. So, but we're not quite at the equator yet. We're coming close, but we're not quite there. So we do where if they're in the same hemisphere, you subtract. If they're in opposite hemispheres, you add. Okay. Because I have to take this distance here plus this distance when they're in opposite hemispheres. Okay. Because I'm actually 23.5 plus another 20 degrees away from perpendicular.
Okay.
Okay.
Yeah.
So it's plus if they're in the opposite hemispheres, minus if they're in the same hemisphere. So if I was at 20 degrees north, then I'm only 3.5 degrees away from where the rays are perpendicular. Okay. So my sun angle is going to be much higher versus in the southern hemisphere right now, it's wintertime. So the sun angle is going to be much lower.
Okay. That makes sense.
All right. And then the zenith angle is kind of like if I have the sun's angle here, the sun angle measures how far up I look to see the sun from the surface of the ground, from the horizon. The zenith angle is this, so it's 90 minus whatever this is, or whatever our sun angle is. Okay. That's to say, how far away from straight overhead would that be for me? So, okay. So solar declination, you can use this formula to figure out 23.5 times the sine of the number of days to the closest equinox. Okay. Yeah. So if you're in between from September 22nd to March 22nd, you're heading, it's going to be negative because you're heading towards March. Okay, that's the best way I can describe it. And then any other time in between March 22nd going towards September, it's going to be a positive declination. Okay. And that's because of we're in the northern hemisphere. So that's what we're using, because we would be in more higher altitude, higher declination than, because it's in the northern hemisphere. So it's going to be positive to us. Okay. And then in between March and it's going to go southern hemisphere. So you're going to do that calculation for our latitude, which is 42 north, and whatever today's date is. So you're going to do figure out how far from the equinox you are, which is kind of a good thing for you guys because it's only a few days versus having to count. In the spring semester, students have to count, sometimes, 40-ish, 50 days, something like that. So they get very angry at me. I'm like, look at a calendar. It's not hard. The next thing you see is the day length. And that's just giving you what the day lengths are at the North Pole and then at a couple of other locations. So Rovaniemi is at 66.5 basically, and that's the Arctic Circle. Okay. And then Cortland, then Dhaka is basically at one of the tropics. Okay. And then Dhaka is at the equator. So it's just kind of giving you the relationship of how day length changes as you move closer to the equator. Okay. So throughout the year. So at the North Pole, what would you say the relationship is over the course of the year? How big of a day length range is there?
Quite a bit.
It's from 0 up to 24 hours. All day. Okay. So that's and then at the equator, what's the day length range?
It's the same, pretty much.
There's no change, right, over that. So the day length range is 0. This one, the day length range is 24. Okay. So we can, as we move away from the equator, what's happening as we move towards the equator. Just make sure you're specific about as latitude increases, as latitude decreases, the day length does blah, blah, blah. Okay. And then you're going to calculate the sun angle, which you're using for those dates. So you go back up to the dates that I gave you up here, and you plug in those latitudes of declination into this equation. Yeah. And whatever the location latitude is that you're given. So you would do that calculation, show that work. Okay. Okay. And you'll get that sun angle. And then you're going to use this equation 1 over the sine of whatever the sun angle is to calculate the beam spread.
Oh, okay. That gives you your beam spread. Okay.
Right. And for this one, like I told, you can use 66.5. That's probably the easiest rather than 0.30 because that will kind of mess it up a little bit. And then this one, I said use 23.5. So I should have put that in this one as well because a lot of students don't realize that 30 minutes is 0.5 degrees. So 10.
Okay.
All right.
Yep.
All right. And then asking you questions about what you've calculated here and the relationships between the latitude and the beam spread, latitude and beam spread for the different days of the year. So what their relationships are.
Okay.
Okay. So always be careful about the relationships. In general, we start with latitude. So as latitude increases, as latitude decreases, such and such happens. Okay. Because we wouldn't say, oh, as sun angle increases, our latitude changes.
No.
Right?
Right.
So it's super important to make sure you write it in the correct way. Okay.
Yeah.
So if you have more questions, feel free to call me. Hopefully that helps you.
I'll plug away with it for a little while here, and then we'll see. When's this due? Next Wednesday?
Yeah.
So we'll have
Plenty
a
of
meeting in
Plenty
between. What's that?
Plenty of time.
Yeah.
You're way ahead of the game.
Time in between there.
Did you want to look at the lab 2 or whatever? Because I don't recall all whatever I commented.
Absolute stupid mistake. I can't even believe it.
Yeah.
For one, I forgot my units, so that's
wait. Hit stop meeting.
Yep.
Hit stop board. Sorry.